Have you ever pondered how the sun, a gigantic ball of blazing gas, plays an indispensable role in our lives? This celestial titan sitting at the heart of our solar system is far more than just a pretty sunrise or sunset. It's our very own star, a beacon that has guided life on Earth from its humble beginnings. The sun is a source of light, casting away the darkness and allowing life to flourish on our planet. It radiates warmth, creating a haven for life amidst the cold void of space. But its influence extends even further. The energy it provides is vital for photosynthesis, the process that sustains plant life and, by extension, all life on Earth. Moreover, the sun shapes our climate, our weather, and even our daily routines. It's a constant, a reassuring presence in our lives. So the sun is not just a luminous celestial body, but a powerhouse that fuels life on Earth. Let's dive deep into the heart of the sun, its core. The core, the sun's central region, is where the real magic happens. Imagine a place so incredibly dense and hot that it facilitates a process known as nuclear fusion. This isn't your everyday chemical reaction. No, it's a process that sees hydrogen atoms, under immense pressure and temperature, come together and combine to form helium. This fusion of atoms isn't just a simple transformation. It's a dance of subatomic particles that culminates in the release of a tremendous amount of energy. It's this energy, born in the heart of the sun, that gives our star its radiant glow, its warmth, and its life-giving properties. But the journey of this energy is only just beginning. From the core, this energy begins its outward journey, starting with the next layer of the sun's magnificent structure, the radiative zone. Beyond the core lies the radiative zone, a shell of highly dense plasma. In this layer, energy generated in the sun's core is transported outward through a process known as radiative diffusion. This energy, primarily in the form of photons, bounces around within this zone, gradually making its way towards the surface. Now imagine a cosmic game of pinball, with photons acting as the balls, ricocheting off particles and moving in a zigzag path. This journey, believe it or not, can take hundreds of thousands of years. But then, as we move further out, we encounter a shift. We've now reached the convective zone. Here, the sun's plasma isn't as dense, and the energy transportation method changes from radiation to convection. Picture hot soup boiling on a stove. The heat rises, cools down, and then sinks back to the bottom to heat up again. That's exactly what's happening in the convective zone. These currents bring the energy closer to the sun's visible surface, the photosphere. Welcome to the photosphere, the sun's visible surface that emits the light we see. The photosphere is a bustling landscape, marked by dark, cooler areas known as sunspots. These sunspots are evidence of the sun's magnetic field at work, an unseen force shaping the visible phenomena. Just above the photosphere, we find the chromosphere. It's a thin yet vital layer where solar material is heated to incredible temperatures, causing it to glow with a reddish hue during a solar eclipse. Beyond the chromosphere is the corona, the sun's outermost layer. It's in the corona where we witness spectacular solar flares and coronal mass ejections, dramatic displays of the sun's dynamic and active nature. These ejections can send streams of charged particles hurtling into space, sometimes reaching our own planet and causing auroras. All these layers, working in harmony, create the sun's magnificent spectacle we witness from Earth. Now, why is understanding the sun so crucial for us? Well, it's because the sun's activities have profound effects on our planet, impacting not just our climate and weather, but also our technological and biological systems. Solar flares, for instance, can disrupt satellite communications and power grids, making the prediction of such phenomena essential. What's more, the sun is our primary source of energy. Harnessing its power through solar energy research holds the key to sustainable and renewable energy solutions. This prospect could revolutionize our energy consumption, significantly reducing our reliance on fossil fuels and mitigating the impacts of climate change. Understanding the sun also lets us peek into the past and future of our own planet, and maybe, just maybe, provides us with clues about the potential for life elsewhere in the universe. So the sun is not just a distant star, but a key player in our lives, our climate, and our future.